we would now move on to our next presentation, which is going to be by Mr. Nitin Prasad, Manager Operations, Tata Power Company. He's going to take us through an interesting spotlight presentation by Jojobera Thermal Power Plant. Before he starts with this presentation, a few words about him, introducing him. Mr. Nitin Bhushan Prasad has 12 years of industrial experience and is presently working at Tata Power. As an operations manager, he is looking after daily operational activities of PF fired boiler, coal mills, boiler feed pumps, ACW system, DMCW system, cooling tower, maintenance activities of boiler, turbine
Hello,
side,
yes,
balance of plant,
I'm
and SCG
apologize because I
equipment.
was in the conference. Now I'm free. Just tell me, you sent me it's for their website, but they never ever read it.
Yeah, sorry for that. And Mr. Prasad, requesting you to please turn your video on and unmute.
It's audible?
Yes, you are audible. Thank you for joining us. I will just give you the rights to share screen. Yes, you could share your screen now.
Are you able to see?
Yes, we're able to see. You would have like 30 minutes for this presentation. Yeah?
Yeah.
Okay, over to you. You could go on the slideshow mode and then you could continue.
It's in slide mode.
I cannot see it on the slideshow mode.
Here it is showing on slide mode.
No, we cannot see it on the slideshow mode. Maybe you want to stop your share screen, and when you share screen, click on the slide, on your slideshow slide. Now the slideshow mode, when you share screen, directly click on that. No, we can still just see the PPT. We cannot see it in the slideshow mode.
Slideshow. Slideshow. Are you able to see?
No, sir. Could you just click on that again? Can the attendees see it in a slideshow? Because I cannot.
Like you are able to see my screen.
I can see your screen. I can see the PPT, but we can't see it in the slideshow. As long as it is readable, it's fine. But otherwise,
yes, slideshow is not visible.
Yeah, the slideshow is not visible.
Oh, it's not coming down.
Would you want us to share screen from our end? You could just quickly pass on the presentation to us. We can do it.
I have to mail you.
Yes, you could just email it to us.
Just a minute.
Mr. Prasad, can you confirm if you have shared the email with us? Mr. Prasad, in the meanwhile, you could just introduce what your presentation would be about. Till then, I will just download it at my end and share screen.
You have got the mail now?
Yeah, we are just downloading it at our end. Till then, in the meanwhile, you could just give your introductory note on the presentation till I'm able to download it.
This is Nitin Prasad from Jojobera Power Plant, Tata Power Jojobera. Here, basically, we are having units of 120 into 5 and megawatt and 67.5 another unit. The total, this is the capacity of the power plant, and all the units are thermal power plant of PF fired. And basically, in order to have the good environment, we are and the emission norm, to follow the emission norms, we have made many initiatives, and one of the initiatives is the NOx abatement system. The NOx system we have implemented in Unit 4 and Unit 5 of the Tata Power Jojobera, and it has been already erected, and the commissioning has been also completed of Unit 5, and full load test we have already done. So basically, we will be showing the parameters of what we have achieved and what the problems we are facing at Jojobera Unit 4 related to the NOx system. And moreover, it is also having a kind of system that is having a DV plus system. Basically, the system is there that basically balances the secondary air inside the boiler, and it basically helps to adjust the total air, and it basically leads to the reduction of total air, and finally the combustion is of good quality, so that the coal also reduces, and finally it enhances the boiler efficiency. You've got my sheet, ma'am?
Yes, I have. I'm just sharing my screen.
Yeah.
Can you see my screen?
Yeah, it's visible.
Can you see it in the slideshow mode?
Yeah, it's slideshow.
Yes, you could
Yeah,
just
you can move
indicate when
forward.
you want me to change the slide. I'll change it accordingly.
Yeah, you can move forward. This is basically scenario. Basically, Jojobera power plant, the customers are major are the Tata Steel, then Tata Motors, then Nuvoco, Cement. Basically, all the power we are giving to Jusco and Cummins. Of total Jamshedpur the power, 71% power is being supplied by Tata Power. The rest 16% in supplied by Tata Steel, that is TISCO, and the rest others are provided by other like DVC and the state government. You can move forward, ma'am. These are the initiatives basically taken. This is the NOx abatement system having the enhancement of digital boiler plus. Then we will be talking about the DFM catalyst firing, And further new initiatives that we will be adding, that is the X-plate technology. These trials are to be taken. Then the green coal technology, that is kind of qualitative trial in unit 1 boiler we will be making out. Kindly move forward. This is the basically the design of the NOx system and the changes that has been taken place. Earlier, the boiler secondary air that was having, in that the 2 ducts have been taken out to increase the supply for the sofa dampers. You can clearly see at the top corners of 4 elevation, top elevation. We have next to the ma'am. Can we move to next slide? This is the basically the baseline test that we have done in unit 4 and 5 in the month of May 22. In this baseline test, basically at full load condition, all the baseline of mill ABC combination and mill BCD combination we have done, and the NOx parameter that we have achieved in the case of full load condition. That is when we take the mill ABC in service, it is around 565. At 75% TMSAR, it is 618. That is milligrams per Newton meter cube. And at 100% TMSAR, with the as we take the mill top mill in service, that's the BCD, it comes to be 620. Basically, the company that has provided GE Technologies, they have guaranteed a value of less than 450 nm cube. Kindly move forward, ma'am. This is our system. In this, this is basically the stage combustion method that has been used to reduce the NOx level in the boiler exit flue gas, which requires addition of basically the sofa dampers at level some gap above the wind box. The sofa system is fitted with 8 numbers control damper, 2 number elevations at each corner to control the secondary airflow through sofa wind box. Additional sofa ducts, sofa panel. These are the extra equipment that have been installed in the sofa system. Yaw is the yaw mechanism. Then tilt has been added in existing boiler to complete the sofa system to reduce the NOx. During the operation of sofa dampers, the auxiliary air dampers likely to reduce to the minimum level. Kindly forward. These are the modifications that has taken. The major modifications have been taken in boiler. The sofa damper assembly at each corner is there. Then the instrument air connection. Basically, the AC/DC dampers. The 2 AC/DC dampers are there, in which one AC/DC damper is being fixed. And these are the sofa dampers. Kindly move forward. Major jobs that has been carried out during the erection, that is fitting of the extra pressure part tubes with the sofa panel and existing observation door. The erection has been completed, and the termination connection of 2 ends of sofa duct has been done. Matching and fitting of sofa duct metallic expansion joints with the boiler duct to the duct, installation and fixing welding of expansion joints as per the drawing, modification, strengthening and installation of the buck stays, rerouting of soot boiler steam pipe due to falling issues. New duct layout scheme has been done. Airlines or any other pipes required to reroute it in case of falling new sofa layout scheme. Modification and relocation of structural member platform stairs, erection fitting and welding of sofa platform with handling. Kindly move forward. These are the new type of coal nozzles that is installed. That is called as basically the diamond shape. Replacement of the tips of the coal air nozzle with the new modified, and erection of coal pipes with the supports has been done. Kindly move forward. Basically, post installation, the trials are going on, and at full load condition, when this NOx system was introduced, so we faced in the starting many problems like while in the startup condition, the furnace pressure while taking the oil gun, it normally it goes to 25 mmWc. But when in the starting of the condition, it gone up to 75 mmWc in the single gun. But with every trial, we have G is in consultation, and they're trying to reduce the things. Physically, the firewall seems to be shifted upward as the intensity of the flame is showing low in the lower elevation. As the firewall has shifted to the higher elevation, in case of any disturbances, what we are facing that any furnace draft fluctuation is there, high probability of elevation A beam may vote for the loss of firewall in spite of healthy flame conditions in CD and D. D flame has no contribution to the firewall logic as neither fitted D or E is in service. Flame intensity of any corner not showing significant variation without oil guns in service. With sofa dampers in open condition, what basically problem we are facing that we are getting low RH temperature compared to earlier, that is 4 to 6 degrees less temperature we are getting. Kindly go forward. These are the key observations and issues. Each dampers earlier were consisting of the 2 flaps, out of which one flap has been made permanently closed by welding, so that at the secondary position, less amount of air goes and more amount of air goes to the sofa damper. So similar damper opening command airflow to the individual damper with a significantly lower. This has been adversely affect the combustion when the oil guns are in service at any elevation. After modification, actually the original curve was you can see at the left hand side, but G has designed a different curve so that the combustion part can be looked after. Kindly move forward. You can see very well. These are the post full of trials of the project that we have done. So earlier, our values were, you can see it was earlier 700 and 600 level milligrams per nm cube. But now, post the project, the values what we have received, that is 409.6. That is well below the value that has been given by MOEF. It is actually 450. We have achieved 409. Kindly move forward. This is the NOx abatement system in which DG plus digital boiler plus DV plus system is being introduced. Basically, in this various type of coal flow sensors are being installed, and edge control analytics is there. Basically, the main purpose of this is at all the elevation, with the coal flow sensors, it establishes that how much amount of coal flow is there, and accordingly it adjusts the acidity of every elevation. So basically, it helps in improving the NOx. Kindly move forward. The digital boiler plus is comprised of the basically the major components are the coal flow sensors. Are there a set of coal flow, 2 numbers in each coal pipe that measures fuel in each of the burner. The coal flow sensors provided fuel air balancing information, and they are located at each coal pipe to further finer control of the air injected. The edge control assembly analytics, a discrete controller assembly is there that gives data and sends individual damper for the fuel air, auxiliary air, and biasing is also provided in the DCS. CO and O2 analyzers are to each or extra provided at each stream of economizer outlet. Individual control for air dampers and actuators. That means that each drive will individually be controlled through the DCS. A new kind of flame scanner is being supplied by GE. That was earlier we were having of BHEL type. Now it has been replaced with the GE type. Kindly forward. Basically, the benefits of DV plus system is it directly helps in reduction of the NOx emissions, reduction in auxiliary power as the total air gets reduced. So we are having a reduction in the aux power, reduction in dry flue gas losses as the total air is decreased, increase in directly in the boiler efficiency, and finally overall plant heat rate improvement is there. Kindly move forward. This is a kind of this is the second initiative. DFM catalyst is there that we have a trial we have done in Unit 1 boiler, and in Unit 1 boiler, this is basically trial has been done in May 22 for a period of 1 month. The baseline test data trial was captured, and the dosing was started. Dosing was started 3rd May with the 4 nozzles to deep holes at 4 corners at AB elevation at total flow of 1.1 of the flow of the DFM catalyst is 1.2 liters, and basically this was constant load of 58 megawatt we have done, and a single coal firing, a middling coal was done in the boiler. And you can very well see in the graph that earlier the coal, the specific coal that we were having, that is being reduced. That specific coal reduction of 5 to 7% is there. The green line basically shows that the specific coal percentage has been reduced. Kindly move forward, ma'am. These are the results. Basically, we have captured all the data that specific coal has reduced. So in that case, the load was kept constant. The vacuum has been also taken into consideration, and the total coal flow, you can very well see that it is being reduced. And finally, all these parameters has led to a improvement in the GHR. Earlier, our gross heat rate was 2654, and with the improvement in the specific coal consumption, the GHR has improved to 2594, and this is basically 6.9 to 3. Around 5% improvement is there. Kindly move forward. These are the upcoming technologies that we are planning to do and incorporate in order to improve the efficiency of the plant. This is basically the XPlate technology. This XPlate technology, basically in this kind of XPlate is provided in the airflow direction, and basically this is there in which the nitrogen and oxygen clusters, they are opened up, and individual O2 molecules are released. The help of this is that as the oxygen is improved, so the combustion improves, and finally the fuel efficiency gets increased. Kindly move forward. The maximum basic benefits of XPlate technology are that the O2 is completely consumed from the air of the complete combustion, reduction in the fuel consumption, and as the fuel is gets reduced, to overall the oxmolar will get reduced, and from the environment point of view, we can say that concentration of NOx, SOx, and carbon dioxide, which is temperature dependent, this also get reduced. Kindly move forward. This is the green coal technology that also we are planning to implement, and basically by use of this, the coal combustion consumption gets reduced by 15 to 20%. Reduction of SOx is there by 30 to 60%, and the reduction of NOx is by 30 to 60%. Kindly move forward. Just move forward. The basic features and benefits of system is that it reduces the accumulation of coal. Scheduled maintenance is being get reduced. Heavy metal impurities to form the complex soft ionic salts are reduced. Reduction of duration of scheduled maintenance. High reduction of high and low temperature correction. The benefits are reduced shutdown translates to increase uptime, increased production of time, and ultimately the increased profit. Prevents calorie loss and spontaneous combustion of coal during shortage up to 6 months. That basically enables us to prolong the shortage of coal stockpiles and allow for a larger order of coal, enabling price savings. Kindly move forward, ma'am. This was the basically these all four systems that we have explained, and all basically process are being done to decrease the NOx emission and increase the combustion efficiency, and finally finally these all led to the decrease of NOx and SOx. And this is all basically our presentation.
So further to explain on this, what Tata Power Jojobera did, particularly we have shown to control the SOx. We are putting up we have put up FGD for controlling NOx. We have put up NOx abatement system.
Ma'am, I would like to introduce our operation head, Mr. Vimal Kumar, and he will also like to tell something about our plant and the new initiatives.
Yeah, right.
Sure.
I was already speaking. Yeah. So what I was speaking on that FGD we have already is there for controlling the SOx and NOx abatement system. What Nitin spoke, we already have for controlling the NOx. Further, boiler DB plus, boiler digital plus is being installed to fine tune further combustions, so that no losses can be incurred. You know, even if we save the losses, then also coal combustion reduces. And further to it, we are along with Shell, we are studying on few alternate fuels which can be fired in the boiler along with coal. So it will be a mix of coal and other fuels also. That study is going on, and with the IIT also, we're doing a study. IIT Bombay, we are doing a study on feasibility of reducing carbon dioxide emissions using solar concentrating collectors. At the beginning, it will be for the feed water preheating. So this will further reduce upon coal consumption, and ultimately CO2 emissions will come down. So these are the further plans. And then to control on SPM, we are putting up HTFR also. And right now, I saw a presentation given by a company on FTR technology. That is also, I mean, the same. We are along with that, along with the company, we are doing. I mean, we are seeing a feasibility for our boilers in that respect also. So many things are planned in future, because this subject being so critical and being so crucial at this stage with the coming up norms, we have multiple initiatives in place to take around and to give a good result, I mean, reduce upon these emissions and all. So this was all from Tata Power side. Thank you.
Thank you, ma'am.
Thank you. Thank you. I will stop the screen sharing now. So yeah, that was yet another case study which brings an end to our 2-day conference.